Hello, in this video we're going to test whether marginal utility of a good diminishes. If marginal utility is positive, consuming more units increases utility. If the slope of marginal utility, that is the derivative of marginal utility, is negative, consuming more units of a good increases utility by smaller and smaller increments. That's the case of diminishing marginal utility. So we're going to do a numerical example. Here's our utility function over good x and good y. First thing we'll do is get marginal utility of good x by taking the partial derivative of the utility function with respect to x. So we got this 1/5 term here on the exponent of x that comes down in front. So that's where this 5 is. And then 1/5 minus 1. We're going to do that to the exponent. And that will leave x raised to the minus 4/5 power. And if we want to follow the rules of exponents, we can take this x raised to this negative exponent and move it down into the denominator. As we can see here that the marginal utility of good x is positive, so this simply means that more is better. As we consume more units of good x, utility increases. What we're interested in trying to show is whether there is diminishing marginal utility. So in order to show that, we are going to take another derivative. We're going to take the derivative of marginal utility with respect to x. So taking the derivative of marginal utility with respect to x. Okay. And what I'm basically doing, I'm taking the derivative of this middle result here with respect to x. It's a little bit simpler. I can avoid the quotient rule. So I'm going to bring down this minus 4/5 in front. Okay, and then minus 4/5 minus 1 over here in the exponent for x. And simplifying, we got minus 4x raised to the minus 9/5 power. And that's also multiplied by this y term, and that's going to be all divided by 25. So regardless of the simplification here, we have a negative sign, so this is going to be negative, and that is an indication we have diminishing marginal utility. As we consume more units of good x, yes, utility increases, but it increases at a decreasing rate. That decreasing rate part indicates diminishing marginal utility. We can do the same thing here for good y. We'll show that good y, its marginal utility is positive. If we consume more of good y, utility increases. So bringing that 4/5 down in front, 4/5 minus 1 leaves us y raised to the minus 1/5 power. Simplifying a little bit over here, regardless we get a positive marginal utility. Taking the derivative of marginal utility with respect to y, so bringing this minus 1/5 down in front. That's where this minus is coming from, and then we got another 5 here in the denominator. Simplifying this further, we get this step or this step, and once again we have a negative here, so we have diminishing marginal utility. As y increases, utility increases, but by smaller and smaller increments. Let's do some other examples. Here we have utility as a function of x and y, but this time we have some natural logs in here. So we get the marginal utility of good x. Following the rules of taking a derivative of natural logs, it's just going to be 1 over x. So that is positive, but what about the second derivative, or taking the derivative of marginal utility with respect to x? Doing this, following the quotient rule, we get a negative sign here, so we have diminishing marginal utility of good x. Doing the same thing for good y, the marginal utility for good y is positive, consuming more of y is better. But if we take the derivative of the marginal utility of good y with respect to good y, once again we can get a negative sign here, diminishing marginal utility for good y. Let's do another example. Here we have a utility function, getting the marginal utility of good x. It's 8. Taking the derivative of marginal utility of good x with respect to x, it's just 0. So here marginal utility does not diminish, but stays constant. In other words, the slope of the marginal utility curve is 0. So we do not have diminishing marginal utility here. We have constant marginal utility. And as for good y, the marginal utility of good y is positive. But the marginal utility of good y, if we were to take the derivative of it, we'd find that it is negative. So we have diminishing marginal utility for good y. Another function here, utility equals x squared times y cubed. The marginal utility of good x is positive. Taking the derivative of the marginal utility of good x, it is also positive. So here we have actually increasing marginal utility. As a consumer consumes more of good x, utility increases, but it increases at an increasing rate. That increasing rate part is coming from the fact that the derivative of the marginal utility of good x is greater than 0 or positive. Likewise, for good y, the marginal utility is positive, so as we consume more of good y, utility increases, but because the derivative of the marginal utility of good y is greater than 0, marginal utility is increasing at an increasing rate. So we have increasing returns here for consuming good y. Okay, I hope you found this video helpful.